Down here, darkness is not just empty. It is crowded, watching, and alive with signals. Over 75% of deep-sea animals create their own light, turning pitch black into a living minefield where every glow could be a trap. Pressure crushes with the force of hundreds of elephants on a single door. Biology should not work, but somehow it does. If you like videos like this and want to help me out, please make sure to leave a like and subscribe so you never miss the next video. This is not about weird creatures. It is proof that life at depth rewrites the rules, and what survives below does not resemble anything we would recognize. How do they do it? Let's go deeper and see what should be impossible. At 4,000 meters below the surface, water stops acting like water. It becomes a force that presses in from every direction, relentless and absolute. The pressure here is 400 times what you would feel standing on the beach. Imagine 100 adult elephants, 50 tons each, balanced on a single door. Now picture that weight not just above you, but pushing in on every inch, squeezing, flattening, leaving no escape. That is the reality for anything that dares to live at these depths. Nothing built for the surface could survive. Human bones would shatter. Submarines built for shallower waters would buckle and crumple like empty cans. Even the toughest steel groans under this kind of load. Survival at these depths demands different rules. For deep-sea creatures, the rules of survival are rewritten from the inside out. Air bladders, the organs that keep fish afloat near the surface, become deadly at depth because they implode or collapse. So deep-sea animals abandon them entirely. Skeletons are thinner, softer, sometimes almost gelatinous. Bodies become pliable, able to yield without breaking. Proteins that fold perfectly at the surface start to unravel under pressure. So these animals pack their cells with special molecules, natural stabilizers that keep their machinery running when the crush should force everything to a halt. Pressure at this level does not just threaten to crush bones or shells. It attacks every part of a living thing, right down to the chemistry that makes life possible. Enzymes and membranes have to be rebuilt from scratch or nothing works. Even the way these animals move changes. Quick bursts of speed waste precious energy and risk structural failure. So most deep-sea creatures drift, glide, or pulse slowly through the water, conserving strength for when it is truly needed. The deeper the descent, the more foreign the solutions. In the Hadal trenches, 6,000 meters and beyond, the ocean becomes a test of what biology can withstand. Here, life is reduced to its most essential parts. No extra bulk, no wasted effort, just adaptations that let it endure a world where the pressure never lets up. Down here, fragile does not mean weak. It means engineered for survival in a place where every second is a negotiation with crushing force. Light is the deep sea's deadliest language. In a world where sunlight never reaches, most animals have learned to make their own light. This isn't just a trick of beauty, it's survival, written in flashes and glows. Down here, more than 3 out of every 4 creatures carry the power to create light. The darkness isn't empty. It's alive with silent signals, each one a message, a warning, or a trap. Some use light as camouflage, blending in by matching the faint shimmer above. A fish drifting through the twilight zone can erase its own shadow with a row of glowing organs along its belly, making it nearly invisible to anything lurking below. Others use light as bait, pulsing a single spot to draw in the curious or the hungry. One wrong move toward that glow, and jaws snap shut before the victim even realizes the danger. In the deep, every flicker could be a lure, and every glow could mean the end. Bioluminescence also serves as an alarm. When threatened, some animals unleash a burst of light, startling predators and buying precious seconds to escape. Others release clouds of glowing fluid, filling the water with confusion. The attacker is left blinded, while the prey slips away into the black. Communication is woven into these displays. Flashes and pulses can signal mates, warn rivals, or coordinate group movements, all in a language that only the right eyes can read. But there is always a risk. A signal meant for one receiver might catch the attention of something far more dangerous. Every message is a gamble, every glow a possible beacon for hunters. The rules of the surface do not apply. In the deep, light is currency and weapon, mask and target. It can save a life or end one. The ocean's darkness is not a hiding place. It is a battlefield fought in wavelengths most eyes will never see. To survive here, you do not just use light. You master it, or you vanish. A small motionless fish floats in the blackness. Its silhouette barely more than a shadow. But its head is something no ordinary animal could wear. A clear, rounded dome like a helmet of glass. Inside, two emerald green eyes point straight up, fixed on the faintest hints of movement above. This is Macropinna microstoma, the barrel eye, first described in 1939. For decades, its true form was a puzzle. Preserved specimens lost their clarity. Only in 2009 did deep-sea cameras reveal the living secret. The entire top of its skull is transparent. The eyes inside can swivel, scanning for prey silhouetted against the last traces of downwelling light. Where most animals see only darkness, the barrel eye's window lets it track meals drifting overhead, jellyfish, tiny crustaceans, anything careless enough to break the outline. Its body is soft, almost gelatinous, built to survive the immense pressure and the slow motion world of the deep. But the real anomaly is that head. No armor, no solid skull, just a living viewport, as if the fish was designed to spy on a world it can never enter. In a place where light means danger, the barrel eye turns its own brain into a lookout post, watching for threats and opportunities in a world where every shadow could be fatal. Not every deep-sea creature is compact or hidden. Some stretch the very idea of what an animal can be. Predation, the giant siphonophore, is a living chain that can reach 40 meters, longer than a blue whale. It drifts in the open water, a fragile, almost invisible thread trailing through the dark. But this is not one animal. It is a colony, hundreds or thousands of specialized units, each with a job. Some sting, some catch, some digest. Together they form a single coordinated trap. The siphonophore hangs in the water, motionless, waiting for anything to brush against its tentacles. A slight touch triggers a cascade. Stingers fire, muscles contract, prey is pulled into the digestive core. The entire structure is delicate, easily torn by currents or careless contact, but in the deep, fragility is a weapon. It can cover vast distances, catching whatever the darkness delivers. Siphonophores show that in the deep, even the concept of a body can be rewritten. The rules bend, a head becomes a window, a body becomes a colony, and survival shapes forms that seem impossible anywhere else. If you like videos like this and want to help me out, please make sure to leave a like and subscribe so you never miss the next video. In the deep, survival isn't just about shape or size. Sometimes, it means rewriting the rules of what bodies can do, or even what it means to be alive. The deep-sea anglerfish is a perfect example. In the endless dark, finding a mate is nearly impossible. Males are born tiny, with barely enough energy to swim and almost no hope of meeting a female in the vast black. So when a male does find a female, he bites down and never lets go. Over time, his body fuses with hers. Skin merges. Blood vessels connect. He loses his eyes, his fins, even his own organs, until all that remains is a lump of flesh feeding off her bloodstream. In some species, a single female carries half a dozen fused males, each just a living attachment, reduced to little more than a source of sperm. It isn't romance. It is a permanent merger, a solution to the problem of isolation so extreme it feels almost surgical. For the anglerfish, survival means never letting go, no matter how strange the cost. But the ocean has even more ways to push life to the edge. The vampire squid drifts in a layer of water that most animals avoid, a zone where oxygen drops to about 3% of what is found at the surface. For most creatures, this is a suffocating barrier, a place where muscles lock up and brains shut down. Yet the vampire squid treats it as home. Its body runs on almost no oxygen, its metabolism slowed to a crawl. When threatened, it does not waste precious energy on a fast escape. Instead, it unfurls its cloak-like arms and releases a cloud of glowing mucus, not ink, filling the water with confusion and light. In these dead zones, every breath is a negotiation, every move a gamble. The vampire squid survives by doing less, by conserving, by turning scarcity into safety. These are not just oddities. They are living records of how far life can bend without breaking. In the deep, bodies fuse, boundaries blur, and survival strategies become almost unrecognizable. What looks impossible on the surface becomes normal in the dark. The ocean's most extreme creatures are not broken. They are proof that biology will try anything to keep going, no matter how strange the rules become. In the midnight depths, where blue-green glows flicker like secret signals, a different kind of predator waits, one that hunts with a weapon almost no one else can even see. The black dragonfish drifts through the dark, carrying its own set of lights along its body. But unlike most deep-sea creatures, it does not just use the usual palette. Lined along its jaw, special organs emit red light, an anomaly in a world tuned to blue-green. To most animals down here, red is invisible. Their eyes are built for the short wavelengths that travel farthest through seawater. Red light vanishes after only a meter or two, swallowed by the darkness. But the dragonfish's eyes are different. It can see the red beam it projects, like shining a private flashlight in a pitch-black room. Prey, blind to anything but blue and green, swim on, unaware that the light is painting them in plain sight for the hunter. The dragonfish closes in, jaws unhinging, and the victim never has a chance to react. Some of the most specialized hunters take this further. The loose-jawed stomides, stoplight loosejaw among them, emit far red light with peaks measured at wavelengths greater than 700 nanometers. This is well beyond the vision of most deep-sea life. Their photophores act like sniper scopes, revealing prey that might as well be invisible to everyone else. Spectral analyses confirm these emissions, and while blue and green dominate the deep, these predators have carved out a channel of light no one else can use. The advantage is absolute. In an ocean full of eyes trained to catch the faintest shimmer, these hunters have found a way to see without being seen. They do not just blend in, they operate in a wavelength that turns the darkness into a one-way mirror. Every flash from their jaws is a question. Who can see this, and who cannot? For anything caught in the beam, there is no warning, just sudden exposure, then silence. This is the deep's most chilling rule. The things that thrive here are not just strange. They are tuned to a spectrum of survival that rewrites what it means to hunt and to hide. Where most light is a trap, these predators use it as a key, unlocking a world where the only thing more dangerous than being seen is not knowing you are visible at all. Far below the reach of sunlight, at depths starting around 6,000 meters, the ocean changes again. This is the Hadal zone, a world pressed between steep trench walls where the pressure climbs past 1,000 atmospheres. It is a place that should erase anything with a backbone. Yet in these trenches, a small pale fish glides just above the sea floor. Pseudoleperis swirae, the Mariana snailfish, holds the record for the deepest confirmed vertebrate, with sightings between 6,898 and 7,966 meters. Measuring depth here is not guesswork. Remotely operated vehicles and baited landers drop into the trenches, their sensors calibrated to track every meter as the pressure mounts. Cameras capture these snailfish alive, swimming where most life would collapse. Their bodies are nearly translucent, bones soft and flexible, organs shielded by a chemistry that resists the crush. Air bladders are gone, replaced by a body that bends instead of breaking. Even their cells are packed with molecules that keep proteins working when surface life would unravel. In the Hadal trenches, the snailfish is not just surviving, it is thriving. In a realm where physics itself draws the border between possible and impossible. At nearly 7,000 meters in the Java Trench, a shape appeared on the remote camera feed, fins outstretched, arms trailing, moving with a slow, ghostly rhythm. It was a Dumbo octopus, a creature named for the fins that flap like ears, but built for a world beyond ordinary comprehension. This sighting, recorded in 2020, stands as the deepest confirmed encounter with a Dumbo octopus. No sunlight has ever touched this layer. The pressure is so intense it would crush most machines, yet this animal moves with effortless calm, its body soft and pliable, its tissues engineered to survive where even proteins begin to unravel. There is no air in its body, no bones to snap, no rigid parts to fail. Instead, every cell is tuned for endurance, every movement a negotiation with physics. The Dumbo octopus does not just live in the abyss, it thrives at the edge of what life can bear. For now, this is as far as our eyes have reached. But the ocean keeps its secrets, and the next descent may reveal something even stranger, waiting in the dark where the rules are still unwritten. Right now, as technology finally exposes the deep, every discovery makes Earth's boundaries feel less certain. Deep-sea creatures succeed in conditions that would destroy almost any known life. It is proof that nature's rulebook isn't finished. The abyss is not empty. It is evolving, adapting, and watching. What else survives out there, rewriting what is possible? If you like this video, please tell us in the comments what video you want to see next, and don't forget to subscribe.